Velkommen til. I kommer alle sammen til at beskæftige jer meget mere med bæredygtighed. Det gælder både jer, der er samlet her fysisk i Additive Hub Danmark i dag, og jer, der sidder bag skærmen. For bæredygtighed og konkurrencekraft hænger uløseligt sammen af 3 grunde. Kunderne kræver det, talenterne kræver det, og investorerne kræver det. I Industriens Fond der vil vi fremme skabelsen af verdens mest bæredygtige produktionssektor her i Danmark. Hvis vi skal få mere bæredygtighed og mere konkurrenceevne, er det afgørende, at virksomhederne nytænker måden, vi udvikler og producerer på. Så derfor har vi i dag valgt at fokusere på 3D-print. Så velkommen til alle. Med de ord vil jeg overlade scenen til Frank, som er direktør for Dansk AM Hub. Dansk AM Hub blev igangsat for 4 år siden af Industriens Fond, og I er jo et nationalt videnscenter for Additive Manufacturing, som vi også kender som 3D-print. Så igen, velkommen til. Hvis I har lyst til at vide mere, så gå ind på Industriens Fonds hjemmeside. Og hvis I har lyst til at vide mere om AM Hub, så har I også en hjemmeside. Frank, scenen er din.
Mange tak. Og tak for initiativet til Industriens Fond. Tak til alle, der er her i dag, og tak til jer derhjemme, der også følger med. Mit navn er som sagt Frank Lorentzen fra Dansk AM Hub. Og vi er en fond, som gør alt, hvad vi overhovedet kan for at få den her teknologi ud i dansk industri. Og det vi skal tale om i dag, det er et super centralt emne. Faktisk så føler jeg, efter at have været rundt i verden, vi har lige været i Detroit og i New York også, at tale med producenter og AM-aktører derovre. Jeg føler faktisk lidt, at det er den største blinde vinkel, vi har i vores industri herhjemme i Danmark i forhold til, hvad det er for et potentiale, vi faktisk kigger ind i. Der er rigtig mange af producenterne derude i dag, som er i gang med at måle på deres værdikæder. Og de måler på deres egen CO2, de måler på det CO2, som deres leverandører har, og de måler bare derudaf. Og så finder de ud af alle sammen det samme, at CO2'en ligger desværre i deres værdikæde. Og det er der en grund til. Og grunden den er, at det kommer fra materialet. Materialer er en kæmpestor slyngel i forhold til klimakrisen. Der er en grund til, at vi slås med Aalborg Portland og andet i det her land. Der er en grund til, at sådan noget som stål, hvis det var et land, så ville det være verdens 5. største udleder. Det ville kun lige slås med plastik, om den skulle have den 5. plads, og cement ville være verdens 3. største. Det er fordi, at det er en kemisk proces, der sker, der laver materialet, som udleder rigtig meget CO2. Man bruger olie til at fyre op under de her fabrikker, og det bruger rigtig meget CO2, og så først skal vi faktisk til at producere med det. Der er rigtig, rigtig meget at gøre i forhold til at få materialer ned. Vi skal have vores samlede materialeforbrug ned, fordi kun på den måde i de næste mange år kan vi gøre en forskel i et bæredygtig produktion her i landet. Det er nu engang sådan, at vi har kun de materialer, vi har, og der går altså en rumtid, før Aalborg Portland er klar med en helt grøn cement, eller før vi kan få en klimaneutral stål. I den tid er vi nødt til at spare på materialerne. Og sådan her har vi været vant til at producere de sidste 40-50 år. Vi fræser noget, eller vi former det. Det er en proces, vi kender. Faktisk så kender mennesket den helt tilbage fra bronzealderen. Og lige pludselig, så dumper der en ny produktionsteknologi ned. Altså det her med, at man kan printe noget og lægge noget lag på lag. Og en ting som den her, som ville måske stå ude ved en vej på en pæl og holde nogle wire, så man kunne køre en præsending op over, den kan lige pludselig komme til at se sådan her ud. Og man kunne måske allerede fornemme det i forhold til, hvordan jeg tog den op. Den er en del lettere. Bum, vi har sparet noget materiale. Vi har også gjort nogle andre ting, og dem skal vi også kigge på i dag, men vi har sparet noget materiale. Og måske, hvis man er helt vild og helt tosset, og man kan noget inden for generativ design, som vi skal tale om i dag, så laver man den sådan her. Og det er et af de største potentialer, vi har i dansk industri. Det kræver viden, det kræver kompetence, og det er noget af det, som jeg ser rigtig meget frem til, at vi får på banen i dag. Og med de ord, så vil jeg lave noget rigtig frækt, fordi vi har gang i et hybrid-event, så vi skal selvfølgelig også have hybrid-sprog på banen, så jeg vil skifte til engelsk og introducere den første taler. Det er sådan i dag, på programmet, at vi har en meget, meget stor international virksomhed på programmet. Vi har en meget, meget stor dansk virksomhed på programmet, og så har vi en lille, mellemstor virksomhed også. Og de arbejder alle sammen på hver deres måde med det her område og opnår fantastiske resultater. So, with that introduction in Danish, Bastian, I think you understood everything fine because you live in Hamburg, which is practically like southern Denmark to us, right, in our mind. Really happy that you could be here and that you took the time. We met first time in 2019, I think, where you also visited our conference. Bastian is the innovation manager in Airbus, and he is actually one of the lead thinkers behind one of the best examples, I think, around generative design and how to utilize this expertise to get down in material, but also create products that are actually lighter in weight, which is a pretty big thing when you work with airplanes. So please give him a round of applause, Bastian Schäfer.
Thank you so much, Frank. Indeed, I understood nothing what you just said. As a Hamburger citizen, I can tell you at least one parts of the city belong to Denmark quite a while ago. I like these neighborhoods, very nice people there. And it's always great to be in Hamburg. But today I'm in Copenhagen. It's actually my second presentation after 3 years of COVID. And I thank you for your invitation very much. It's great to be here and to talk about advancements in 3D printing, but also generative design. Before I start, the innovation ecosystem at Airbus has changed dramatically. Due to COVID, people tried to find new orientations outside of Airbus. So we've rearranged the processes that we are running in the in our innovation departments. We are today looking for much closer collaborations with startups in different areas. But we also want to create our own startups in order to go with our knowledge into adjacent markets. This is important for Airbus as it prepares the future of the company in the end of the day. And I believe additive manufacturing will also play a major role there and everything that belongs to that. So the last time when I've been here together with David Benjamin from a small company that belongs to Autodesk called The Living, we were talking about different approaches of generative design. So we have been talking a little bit about our Bionic Partition that you can see at the right-hand side. We've been talking about complex structures, structures that belong to a vertical tail plane, that you can see in the middle of the screen, where we have actually tried to create a lattice structure that responds to bird strike requirements. And we've taken these processes in order to optimize the production processes at Airbus. And we were looking also not only at part designs anymore, we were looking at factory designs. And this is super interesting. So the big gift that additive manufacturing gave us was maybe not the production technology, but it was the advancement in new design principles that can be applied in other areas as well. So let's talk about the first partition, the Bionic Partition 1.0. To recap this a little bit, this project is quite old, and we have been looking at slime mold algorithms that we used to create a design of a lattice structure for a cabin partition. And we've been designing thousands of such kind of solutions, and we were using big data analytics in the end of the day to identify which is the best performing design. So you can see it on the right-hand side that we always try to put different design solutions in a graph in order to better understand what's the weight and what's the technical performance of that component. I also will talk about a partition 2.0 and 3.0, but all of these partitions have one in common. We wanted to decouple the core structure, which is made from metal, from the decorative elements, such as covers and so on, in order to have an increased recyclability. So environmental topics, environmental concerns also play a major role when we talk about additive manufacturing, because additive manufacturing in general will allow us to reduce the weight, and in the area of aviation, this is basically one of the key facts to decrease cost and to improve the product performance. So the partitions I want to talk today about are shown here. So at the very right-hand side, you can see the standard partition, which had a weight of 65 kilograms at that time. It comes with a technical performance where we measure the deflection of such a kind of panel under a 9G force. The first partition we did, and you maybe noticed that some mass indications are missing here. I come to that later. The first partition we did was completely made from or by 3D printing, by additive manufacturing, as we say. Made from scandium or scalm alloy, which is an aluminum magnesium scandium alloy, which is only, well, which we can only create in a 3D printing process. Because of the chemical behavior of the material, we need very high cooling rates that the material is getting finally its properties. So we cannot use this scalm alloy material with casting or even milling processes, because we really need this cool down in the build chamber. The second partition was a one-shot design for casting. Why do I say casting? Because we have been teaming up with a company who printed the entire tooling of that. So we moved from direct printing to indirect printing in order to harness the cost benefits that casting can bring to us. And the final partition I want to talk about today goes back to a very traditional process where we were looking at CNC milling. But before we talk about other partitions, I just want to show some pictures from our test campaign of the first Bionic Partition, which is fully 3D printed. So you can see here at the right-hand side the test rig with the partition. We did this 3 years ago in a laboratory at the TÜV Rheinland in Cologne. And you can see a lot of chains there. So what we did here with the test, or with one of the tests, was that we had a cylinder that pulls 5 tons, and we had to distribute this force to dedicated points at the partition. And so we had a construction in front of the partition, which is called wiffle tree, that allows us to really distribute this high force into all areas. In the middle, you can see how we managed the connections. So that was a project in itself to really make the best design for a component that was 3D printed in the end of the day. And at the left-hand side, you can see also a very interesting picture. This is the so-called upward force test. So we were looking at forces that go up. So we turned everything down and just put some weights on that. The result of these tests was that we almost satisfied our 9G static test. So unfortunately, the partition was broken at a certain point, not due to the use of generative design, but because I have designed a bad component that was the root cause of the collapse of this component in the end of the day. But I can tell you, we all have been impressed how great such a design made from lattice structures is in the end of the day. So with some tweaks and some redesigns, I'm pretty sure this partition would also resist such kind of forces that we require. This is one of my favorite pictures that I want to show you. This is the entire process how to design a bionic partition. And what we are talking about is this small image here in the center, start laser. This is what the entire industry is talking about. We can get manufacturing ready components right away and just have to push a button in order to build a component. But this is not true. Additive manufacturing comes with a long process, especially when we talk about certification for aircraft components. So especially here in the center, you can see all processes and post-production processes that are required that you have one component in the end of the day in your hands. So you find here, for instance, removal of support structures, CT scanning, and other tests and quality assurance tests that we have to fulfill. And the rest of that is data management and production of other components such as the decorative panels and so on. I just want to show you this because it's really important to understand there is a lot of knowledge in the entire process of additive manufacturing. And ideally, one day, we can automate as much as possible in this process to make additive manufacturing more cost efficient and usable and scalable over other components. When you have such a kind of process, you quickly will think about using eventually blockchain technology in order to make the data management. And this is exactly what we did. We did a life cycle assessment for this partition where we have been using the processes. And in the end of the day, and this is going to be presented in 2 months in Berlin, we've been participating in a funded project where we built a blockchain for the entire production process for the Bionic Partition based on the diagram I've been showing you here. So this is also one of the key ingredients in order to automate the process even further. If you have a lot of processes, try to automate them, and eventually blockchain technology may play a role here in order to secure and validate your data and finally also the hardware of the partition. When we have been finishing this, we were looking at a potential factory that can produce, in the end of the day, 700 of such kind of partitions. I would like to highlight these green boxes here. These are printers, and at that time we've been selecting the X1000 from Concept Laser as our baseline machine because it's big and it can produce a lot of components in a relatively short time. But you can see, even to produce one major part for an airplane with a production rate of eventually 700 pieces per year, you need a pretty large facility to do that. So here you have the printing processes, and here in this area you have all the post-production processes that you need in order to have one part ready in the end of the day. And of course, we have design offices here. So in the end of the day, 14 people would work in such a kind of facility, and the cost of such a kind of facility would be between $30 and $50 million. And if this is your special topic, looking at production facilities, you may see 30 to 50 million. It's a big price for such a kind of high-tech factory in the end of the day. Nevertheless, it gave us a certain understanding of how big the effort is to bring one part into an airplane. And of course, and this is what we have presented last time, we can use generative design in order to optimize also these layouts, as we have been presenting in other projects at Airbus, where we were looking at the projects and then designed the envelope of the building around that. This is a great approach which is brought by generative design to us, and which has its roots in our 3D printing projects in the end of the day. So the Bionic Partition 2.0, what did we change? the design process is pretty much the same. So we still have Pareto fronts that we are using to identify the best design. We still have a macro optimization that tells us where the bars are running. The difference this time is we had to change the micro design. So we moved away from lattice structures in order to use structures that can be casted. So ideally hollow structures. And this is our macro optimization, or our micro optimization, sorry, that tells us which of these bars could potentially fit best into the different areas of the partition. Finally, we have selected only one bar, and we used a certain kind of parametrization in order to make this fit in all areas here. And this is possible. We can cast this in one shot in the end of the day, and the part is super light. Here are some other images because I just want to tell you, we not only have been doing one design, we were looking at multiple designs, and this is what generative design brings you. So you will never get the one correct answer from the computer. You always need your ingenuity in order to assess which design is the best one. And you may notice that the performance of these designs is always different. So coming from 30 kilos down to 26 kilograms, the technical performance is always different. And so we won't get rid of engineers, even if we automate such kind of designs in the end of the day. So especially our stress engineers have to assess each and every design and help us to select the best one. Here are some images that we have received, where we have performing some CT high-resolution images. You can see the material is really nice. We also saw this with additive manufactured parts. Why I'm showing this? When I'm doing for additive manufactured parts CT checks, and when I have lattice structures, you will not see anything here in these images. You need some kind of other intelligence that helps you to identify cracks in such kind of parts. This is an advantage that I would associate more than with casting components, because the material is pretty much clean and you have a much better quality control in the end of the day. Let's take a closer look at the partition 3.0. Why did we do the partition 3.0? The first partition was not cost efficient enough. So to be frank, the cost of a fully qualified Bionic partition made from 3D printing would be 10 times the price that we wanted to have in the end of the day, due to lack of automation, but the industry is working on that, and other factors, of course. And so we have been looking at a very traditional way of producing this part. And we had 3 approaches here. One was to use high-speed milling tools in order to create these double T beams. Then we were thinking about using laser cutting or water jetting in order to combine a plate with an optimized 3D structure. And in the end of the day, we also thought about riveting. So when we moved on, we said that we want to go with high-speed milling and mill this entire partition, which has a height of more than 2 meters and a width of 150 almost, from one big piece of aluminum. Of course, you have a bad buy-to-fly ratio here, but we said eventually we can recycle the material, which is waste in our case. So there's always this trade-off. If I'm looking more at a buy-to-fly ratio where I really want to use all the material, I would prefer to go with 3D printing. But when I look more at high-speed milling, in order to reduce the cost I would go with a more traditional way. And so we did a design that fits the toolings we have been using for this partition. So for instance, we had different high-speed milling tools that create T-slots, for instance, and we used them depending on the general design and layup of all these struts here. So here are some images. This was the aluminum plate that we have been using, and here is the final product. You may see here is one part missing. This part is called stretcher flap. To produce one stretcher flap with 3D printing, it took me 1 week and 1 batch to do that. When I go to milling processes, it takes me 30 minutes. Yeah. So the batch that I had to print took me 1 week, almost 5 days. Yeah. So you can see there's still some homework to do to bring additive manufacturing up to speed. But again, the first partition was done a couple of years ago, where we only had 1 or 2 laser machines. Also, some details here. Even if we use traditional technologies here, not everything is fine. You can see here are some scratches in this very narrow radius. So also, CNC milling doesn't come for free. It also requires here a little bit of research, but the entire design was great. And this time I did not have bloody hands because I did not have to assemble all the parts here that I had to do with the 3D printed parts. In the end of the day, what is the result? In terms of 3D printing, we were able to reduce the mass by 46%. So from 65 kilograms down to 35. Mission accomplished. You don't see this very often when you do aircraft components. But what was really surprising for me, when we are printing the tooling and go with casting technologies, we even can drop the weight further, because with a 3D printed design, I had titanium connectors to consider, which make the entire part, again, a little bit more heavy. Here, it was a one-shot casting approach. And finally, the partition that is using CNC milling comes to the same level of weight reduction like the 3D printed partition. And this is a great learning curve. Yeah? Here we have developed the algorithms, and here we applied them to more traditional production technologies. So maybe 1 or 2 words on my conclusion. Additive manufacturing, for our case, is still too expensive. So look for multifunctional parts that require a lot of labor. Casting and machining have some advantages here. Also the quality control, looking at all the processes that we have, like CT scanning and so on. You will have to consider more processes when you go with additive. It's better when you go with casting or machining. It's easier, let's say it this way. And the weight reduction is in all cases great, which refers back to the generative design process. One thing that we did in the past 2 or 3 years was looking at aircraft studies. So we've been looking at a generative design process for a blended wing body, for instance, where we can change the main parameters of this air vehicle. So we want to use generative design over scales, 3D printing, machining, casting for small parts, and process optimization for larger elements like aircrafts and so on. And we also did this study for a supersonic airplane. And also here, we did a concept where we had a wireframe model, which is our macro optimization. Each one of the dots represents center of gravity, center of lift, and so on, or where we find the engines. And our micro optimization was then to create the surface around that. And this really works. This was done by one of my students using a Rhino and Grasshopper in the end of the day. Okay, that should be my final slide. So the last slide is missing, unfortunately. Thank you for your attention and for listening. And if you have questions, feel free to ask them now.
Thank you, Bastian. And for you at home, we have a chat also where you can fire away questions. So just do that. Also, from us, we think this example is really great. Also, one of the great things is that it's at least in the additive version in the Bionic Partition 1, that it's actually rather old. I think it's like 5 years old or something now.
We presented this 2015, I think.
Yeah.
But also the second partition, as I said, had to do something with 3D printing, but not direct, indirect. You go for toolings.
But typically you see that in a production system or setup where they would start with an additive process, that as soon as you start, go for volume or go for scale, that you would shift into the more traditional manufacturing systems because they are more efficient, right?
Yes, I would use nothing else than 3D printers to do my first parts. That's why we have 3D printing farms at Airbus, low-cost printers that we are using with low-cost materials to really just print out a part or a tool that you can assess then further on. We are also now starting to build them into our test airplanes, parts that are made from plastic, just in order to look if they are working.
Yeah.
And this is a great approach. And as you said, at a later stage, when you want to commercialize something, then you also should consider more traditional technologies, which are sometimes not too far from the 3D printed ones.
Yeah. And can you take us a little bit inside Airbus here? Because if you wouldn't have the Additive Manufacturing Bionic Partition 1, would you be able to skip that? Or was that necessary to get you to the third partition?
That was necessary to get us to the third partition, because with the first Bionic Partition, we developed all the processes that we needed. It was for us important to understand the validation process, to work together with our stress engineers that have to validate FE models and then really look at the test results in the end of the day. And we just took this one-to-one, changed the manufacturing requirements in the end of the day, but used the same process to go for the second and third partition in the end of the day.
And I noticed you had that Lca project also. Can you tell us a little bit about that around the Lca? Did you do a Lca between the 3 different partitions, or is it just on the one side?
No, it was just a comparison between the state-of-the-art partition and the 3D printed partition. And one of the main factors that was important, the more powder you can reuse in your process, the better the entire process gets. And this is important to know. It's not easy to remove the powder from the 3D printer and to put this under oxygen conditions that you can reuse it for the next round of manufacturing. When you can improve this, or keep the recycling rate very high, you have tremendous benefits. But the main benefits, of course, came because we were able to print the first time lattice structures which are lighter than the traditional framework we were using.
Okay. And one last question: how do you use generative design inside Airbus in your work? Is that the fallback go-to kind of software, or is it you point to difficult geometries, or where you want to specifically obtain weight reduction? So how do you navigate in terms of generative design?
We have a very large team at Airbus that are looking at digital design and manufacturing methods, and They are aware of generative design, of course, and some aspects are used by them. It's not a software, it's more a process or way of thinking in the end of the day. But at Airbus, we call this a system of systems optimization. So we want to have or define subsystems in a way that we can exchange them in order to assess what's the effect on the main system, which is an airplane or the worldwide supply chain, for instance. But we certainly will go into a direction where we try to simulate everything and also simulate global supply chain effects. We saw this during COVID. It's super important for every company to be aware what's coming up and how you can handle that in the end of the day in order to not get in trouble with your company and with your revenues.
Cool. Thank you very much, Bastian. I will just speak a little bit because I know we have another presenter and presentation now. We're ready to go. Let me introduce Niklas Franke, Head of Additive Design. Am I saying that right? Yeah. And I met Niklas first time, I think, 2 years ago or something, when I first started as CEO in the Danish AM Hub. And I went around all the Danish large producers and the small, medium-sized producers because I wanted to figure out what is this? What is this additive game all about? And how do you utilize that technology in Danish industry? And what I met, kind of the same point that was there was, you can only be good at additive if you have an additive mindset. And then I thought, oh my God, that didn't give me much because what is that then? And I hope you can put a bit more words to it because I remember you told me that you need to have an additive mindset. And if you think about it, the industry that we've built is all around 2D objects. And suddenly we have this technology. And only if you can design for it, you will be able to utilize the true potential. So glad you're here, Niklas Franke. And please give him a warm welcome.
Yeah, thanks, Frank, for welcoming me. Hi to everybody here in the audience, also here joining virtually. I'm Niklas. I'm working for Danfoss, to be specific, Danfoss Climate Solutions, so one of the 3 segments in Danfoss. And I'm the head of Additive Design Manufacturing. So I'm responsible to ensure that 3D printing is used in my segment where it makes sense. And today I want to talk a bit more about why design for additive manufacturing really matters and how it's being used at Danfoss. What you see here is some nice, exciting technologies, 3D print technologies. But in the end of the day, for Danfoss, it's just another tool. It's another manufacturing method. So you have to treat it like that. And I want to show why design for additive manufacturing is relevant to really become successful with this technology. At Danfoss, we started about 5 years ago to really strategically look at additive design manufacturing. And the 3 areas that we're looking at is prototyping, tooling, and components. Before that time, so 5 years earlier, we just looked at prototyping, very segmented. We had some printers here and there, but we didn't look at it from a strategic point of view. This changed a lot over the past few years. You see on the graphic, in these 3 main areas, prototyping, tooling, and components, the stakes are different and the potential is much, much different. Prototyping is like the very old shoe that we're wearing for a long, long time. The potential of tooling is much, much bigger than what we see in prototyping. And then in comparison to that, the potential for 3D printing for serious production for end components is much larger. And in fact, actually the real potential, the graph would need to go through the roof here. So it's simplified here. And it's really 3D printing using for additive, for end components, we see a lot of potential for new business opportunities. So that's the goal that we have. And I want to talk a bit more about why design is relevant to meet that goal. Some more background. When you want to be successful with additive manufacturing, you really have to understand what are the economics behind it. Where does it really make sense? And in essence, if you compare additive manufacturing with conventional manufacturing, in in conventional processes like injection molding, you typically have quite high investments in the beginning, sunk cost. You have to buy a mold that you need to have to automatize. But once you have this investment, it's really great for large volume series production. Additive manufacturing, on the other hand, you don't have these high costs in the beginning, so it lends itself more to the lower quantities. And now, based on that, kind of what is the impact that design for additive manufacturing could have on that? And for me, it's all about value for money. You kind of have to master this game to really kind of be successful in using this technology. And I mean, some challenges about that we already heard in the meeting before. For me, design for additive manufacturing is really critical here because it can both influence the value that you can create with the design freedom of the technology, but at the same time also the money that you spend on it. And kind of this principle applies to all manufacturing technologies, but I would claim for 3D printing, it's much, much higher, the impact of the design aspect of it. In terms of value that you can create, in Airbus, they're very much interested in lightweighting it, because fuel efficiency, but you can also have more compact designs, you can have more longer lifetime of parts, better performance, energy efficiency, for example. That's a very big topic for Danfoss. And for example, also parts which are easy to maintain or assemble. And then also customization. That's, for example, a big topic in the medical sector. And when you look at the money side of it, the big factor is really the size of the part. With the Airbus case, we heard large parts, 2 meters high. You really need to create a lot of value to make a good business case there. So size really matters when you want to produce in higher quantities, and also the process that you select. And it's kind of really this here that you have to master, that you understand this kind of design thinking and what's really behind it. And I try to shed some more light on that. Based on this background, I mostly want to focus on these AM design principles. What is basically the workflow and the thinking that you have to implement to kind of really see where does it make sense, where doesn't it make sense. And depending on your starting point, there are either kind of 3 or 4 phases that you're going through. If you're starting from scratch, you're really just looking at, okay, what is the optimal solution to my problem? And that's, for example, where simulation can be the main driver, as we've seen at Airbus. And the second step is then, okay, you have a result, but maybe there's even some more potential to reduce the weight and the part size. Because again, size matters here. And in the end, of course, also, what is the manufacturing method to reduce costs even further? In Danfoss' case, we're not often starting from scratch, but we have to integrate our additive solution into something already existing. So we often also start with consolidating something that's already out there and then start optimizing it. And in essence, point 1 and 2, consolidation and optimization, that's kind of where you create the value as much as possible and reduce part size and use material and optimize manufacturability. That's where you reduce the money spent on it. And I want to now show a lot of samples which feed into each of these areas. So the first one is consolidation of assemblies and functionalities. On the left side, you see a fairly large metal part, roughly this size. It is a sensor. And this is basically the first design iterations. Whatever comes after that is even more advanced. I can't show you, so just the first iteration here. But basically, traditionally it has been made from a lot of cut metal parts and then welded together. So here we have an assembly reduction from 10 to 1 piece. And even with this just basic consolidation, no more further optimization, we could already break even with traditional manufacturing because the volume was rather low, lower than 1,000 pieces. And then the following steps, we did much more optimization to reduce costs even further. And on the right side, you see a gripper case. These are fixtures used for carrying our products in the factory. And just on buying new of these grippers, because they wear down, Danfoss spends about 50,000 euros every year in Mexico. So it's like a series production, even though it's just used in the factory. And here also the first step was just look at the entire assembly and kind of see, okay, what can you merge together? And here is just 3 to 1. And you will see this example coming up at a later stage again. So consolidate what's possible. First step. Next, optimize the performance. And here I just have some simpler examples, but I will go into that at the end as well. We have here one tool, maybe in some other articles you might have seen this before. It is a tool which needed to be lightweighted for better ergonomics. It's used in the factory in France where they assemble compressors. And this assembly process, it's mostly manual. So these tools are carried around several hundred times each day by the operator. Normally it was machined from aluminum, weighed about, I think, 1.5 kilos. And now we looked at 3D printing with the design freedom, how much could we optimize it? And we came with this nice solution where we lightweighted it with this lattice. And the result was that, well, the part was more expensive, indeed twice the price, but we saved about 76% of the weight. And on top of that, because we switched from aluminum to titanium, the lifetime of the part is probably 5-6 times higher. So in the end, great business case. Then also continuing with this one, how to optimize it. Earlier you saw this consolidated part. Then the next task was, okay, let's optimize it. And here again, we used also generative design on this rather simple application. So here we started with some preserved starting geometries, and all the rest, the ergonomic structure around, was done by the computer, by the simulation. And here we now have this really optimized for the load case, this tool. It's not tested yet, but we are still developing it. And here my prediction would be that, just like this, it will probably last several times longer while costing just half. Then going from optimizing performance, from the value creation part into the cost reduction part, reduce material and part size. Here a graphic, and actually it's nice that the samples that I have here are also here. To really understand this graphic, you really have to understand that 3D printing is basically a batch process. Meaning, let's say this is the build plate, and the larger the part is, you could fit maybe one large part, the airframe from Airbus, maybe one per build job, but the smaller the part is, the more you will be able to fit in there at basically the same cost as you paid for the one large part. So this piece here is basically 100% of the cost. You start here, but then when you reduce the size and the used material, you can really reduce the cost. And in this case, it was really less material, less size, and here I estimated to be like a 6% reduction. And then basically you also have to reduce the cost by nearly 6%. So size really matters because of that. And for that reason also, 3D printing really lends itself to smaller parts if you want to produce in larger quantities. So if you want to print an airframe divider, the goal should really be to create as much value or print something smaller. For example, here, a very small bag with 15 seals, which are used for leakage testing, again in our Mexico factory. These seals have been normally compression molded, and the factory uses 260,000 pieces per year. And since the part is so small, so really at this end, it's very, very cost effective compared to traditional manufacturing. And here we just ordered 200,000 of these, and it's cheaper than conventional manufacturing molding. So every year, Danfoss will produce or will order 200,000 of those. So really size matters if you want to go into serious production. Another benefit is, if you use less material, there's also less stress in the manufacturing process, which typically leads to better quality. That's another nice add-on. There are a lot of different ways to reduce the used material and use size, and all of that has, of course, an impact on the sustainability of your production. A very simple, cheap way is just to take one design and remove any material needed. That's the case here. That was one accessory for one of our pumps. On the left side, the traditional design, 3 parts, machined for metal. And since the volume was so low, I just said, okay, there needs to be a better way to do that. So I just consolidated it all together and just took the inner structure and added 4 millimeters on top of that. Very, very basic, but now 3D printing makes sense here. Before it didn't make sense. That's really why design matters here. Besides this kind of very simple just removing all unnecessary materials. You can also again use generative design to use just the material needed to reduce cost. And here there's an example for a fixture used for our heat exchanger testing. On the left you see kind of the very traditional design, cut, welded together, and with simulation we were able to kind of slightly undercut the traditional cost. So simulation can be used both for value creation but also cost reduction here. And also the other ways, like latticing, just as I did here. Here is a simple tray. It was fairly large, so it was quite expensive to print in the beginning. So here we just took away some material to make it cheaper. And here, in fact, actually, we didn't do any fancy software. We just used an online tool, vornator.com, which worked very nice. So very accessible. And again, also here, not only cost reduced, but also initially we had some issues with warping. Reducing material, no more warping. Better quality, better price. And now the last topic that I want to go into is optimize for manufacturability. I have it here as the last building block, but of course, when you start this design thinking process, you're more or less already sure kind of what would be the best technology from the start on. So in the end, it's basically just kind of the last tweaking to make it most cost effective. And there are different aspects. One is, for example, support structures. You might have heard of it. It adds cost, machining cost, material cost, labor cost, because there will be some poor tool have to remove all of this. This should be reduced. There probably could be somebody talking for hours just on this topic. I try to keep it simple. Just look at a tree, how it grows, somewhere towards the sun, 45-degree angle. If kind of keep this simple rule, probably you won't need any support structures. And that's also what we see here. It's kind of growing up organically, roughly 45 degrees. If you follow this, you will make sure costs will be kept to a minimum. Once you kind of optimize the production of one part, you have to look at the entire build job, because there could be several parts fitting into that. And there is a topic of part nesting, which is relevant to fit as many parts as possible. Here we had a case. It is a brazing cover, a heat shield, roughly football size, really large, cylindrical, and in the initial design, just about 11 parts, well, 10 parts fit into the build job. But just by changing slightly the design, making it a bit more open, we could stack it much better together. And now 22 parts fit. So if this is 100% cost, this might be 120, 130% cost, but more than double the output. That's again why why design matters here. And also there is, once you've printed the part, there's probably also some considerations about the post-processing that you have to do. That is one fixture for thermostats used in the factory. They needed 2,000 new ones. So we looked at 3D printing. And the initial design, we could just easily print it. But because we needed 2,000 pieces, we also had to look, okay, how easily can you automate it throughout all processes? And when you want to print these 2,000 plastic, you want to do automated powder removal. So that's why we opened the part up here. So when the part is being cleaned, it's basically a big drum, turning, glass beads blast into it. Every inside surface should be hit by these glass beads. And by opening it up, we could ensure that the part is properly cleaned. So it's really design thinking through every individual process to get the most value for the money spent. And this, now basically at the end, this is kind of the design flow that I really kind of try preaching within Danfoss. One area that has been kind of underrepresented, I would say, is really optimized performance. That's, I think, something where at Danfoss we just get started with the sustainability aspect. Danfoss now made decarbonization really top of our agenda. We want to become our preferred decarbonization partner for our customers. And with this aspect, I think it will be much easier for us in the future to sell this added value, even if it might cost more. In the past, it has been quite difficult from time to time. So this will be the major driver for all the future success stories at Danfoss.
Thank you, Niklas. Thank you very much. And there is a lot of case examples here, and a lot to take in. If you are small, medium-sized producer somewhere in Denmark and watching us now, I can imagine that they would also feel a little bit, where do I start? If I want to join this additive manufacturing journey and get a little bit better at that, start harnessing some of the potential that we've heard today, what would your advice be? I know it's a difficult, fluffy question, but where would you start? Would you start looking in your production facility? Would you start using it for prototypes? Would you start reaching out to some of the good people in Denmark that actually have printers and can print? What would you do?
Start simple, I would say. First of all, don't try to grab for the stars. Don't try to do rocket science. Start simple, because what matters is that whatever you do, be successful, because then you can build up on that. What I did for Danfoss Climate Solutions is really focus on the tooling side of it, because the difference between the tooling use case and serious production is just the quantities are higher. But else we can treat it the same. So we do use 3D printing and tooling like our playground to learn and also to fail, and then take this learning to the next level. So start simple and also start internally with maybe your first simple 3D printers, but also be at the same time be machine and material agnostic. So at Danfoss, for example, we don't have any metal printers. All this done was externally. So think simple, start simple.
Cool. Thank you very much, Niklas. I have been told that there is a little bit of trouble with the questions out there and bringing them in, so really sorry about that. We will keep moving now, literally, because we have a really, really cool small, medium-sized company in Denmark called Ceramic Speed, just around 100 employees. Actually, we have around 16 or 17,000 producers within that size range. And also they are really, right now they are really hot, because we will have the Tour de France in Denmark in a month or so. So I'm very, very happy that Carsten Ebbesen is here. He's on the link also, and in the presentation. Carsten, can you hear us?
Yes, clear.
Thank you. Nice to hear you. Nice to see you. And Carsten, please do take it away. And I will just interrupt you when we're out of time. But thank you very much for being here. And we will give you a round of applause here in the studio. And hopefully it will travel all the way to your location. So thank you for being here.
Welcome. Hi, everybody. I have made my presentation in Danish. Actually, I changed it from English to Danish, so I hope it's okay to move forward in Danish. And but if you have some questions, you can always write in English. No problem, and also in German. Okay. Ceramic Speed. We are a medium company, about 100 employees. Jeg skal lige på dansk. Vi er et selskab med cirka godt 100 medarbejdere, og laver lejer til industrien med keramiske kugler, det vi kalder hybridlejer. Og så har vi en ret stor del af os, hvor butikken laver dele til cykelsporten. Så jeg vil lige klikke videre til næste slide her. Jeg kan ikke se, kan I? Den burde være skiftet nu. Jo, der var den. Der er lidt forsinkelse på her. Ja, hvis I kan se, så har vi en masse partnere, OEM-partnere inden for cykelsporten. Det er nogle af de helt store, rent faktisk, vi servicerer. Og så har vi selvfølgelig en masse OEM-kunder, AM-kunder, som køber ved butikker over hele verden. Vi er faktisk præsenteret overalt i verden, undtagen i Rusland selvfølgelig. Det var meget heldigt. Ja, de her teams, som vi servicerer, det er jo så, som vi sponsorerer som kører med vores komponenter. Det er Stana, Israel og Quickstep og Intermarché og så videre dernede af. Total Energy, og det er også dem, I kender fra Tour de France. Så vi har rygende travlt lige nu med at forberede en hel masse i forbindelse med Tour de France-starten i Danmark. Det er blandt andet derfor, jeg ikke har kørt til København i dag. Yes, vi skal videre til det, som der er interessant. Vi har, det er vores product range inden for cykelsporten. Og det, der er vores high runner, det er den her oversize, der er vist herude til venstre. Og det er en, vi opfandt for omkring 6,5 år siden. Og det går på, det er dem, der kender til en cykel med udvendig gear, de ved, der sidder en gearskifter og fører kæden op og ned af en kassette med forskellige størrelser på tandhjul. Og der fandt vi så ud af, at jo større et tandhjul, jo mindre friktion er der, når en kæde den skal bukke. Den skal simpelthen bukke mindre, når du har flere tænder. Og det reducerer så den her, det vi kalder artikulation. Og der lavede vi så sådan et oversize system her, som passer til alle forskellige 10, 11 og 12 speed grupper nu. Og det giver faktisk en besparelse på mellem 30 og 60% af den mekaniske friktion. Det er en væsentlig besparelse, når man ligger og cykler i mange timer. Det kan faktisk blive til mange sekunder, man sparer over flere timer. Så det vi så gjorde, det var, at vi satte til at tænke, hvordan kan vi gøre det her, vi kalder det OSPW, Oversized Pulley Wheel, endnu bedre og endnu mere eksklusivt end det vi har i dag. Fordi det vi laver, det er eksklusive dele, det er meget dyre dele til folks meget dyre cykler. Vi satte bare ned, hvordan kunne vi gøre det her endnu bedre og endnu mere eksklusivt. Og så kom ideen op at bruge AM, altså 3D-print, til at skabe et bedre og mere bæredygtigt produkt. Og så fokus på topologioptimering, altså at udhule produkterne. Og selvfølgelig for at spare materiale, og så få en lavere vægt derigennem. Og så samtidig med at prøve at lave et unikt design, og så bruge et eksklusivt materiale. Og så selvfølgelig forudsætningen, det var at bibeholde fordelene, det er, at den skulle være kompatibel med de bagskifter, eller de her oversize-systemer, vi laver i forvejen, og skulle stadigvæk give den her friktion, så vi skulle beholde størrelsen på de her puljehjul. Og så det første vi gjorde, det var, i og med at vi kunne hurtigt se, at vi havde frie designgrænser. Fordi det vi havde designet før, det var baseret på, hvad kan man fremstille med en fræser, altså på en 5-akset maskine. Så vi kontaktede en designer, og så gav vi ham sådan set frie hænder. Og som jeg også lige har sagt, det er muligt, når man snakker Additive Manufacturing. Og så samtidig så kontaktede vi Teknologisk Institut, som er eksperter inden for topologioptimering og alle former for AM, inklusiv den efterfølgende bearbejdning. Fordi som Bastian han også nævnte, og det vil jeg også sætte en tyk streg under, det er ikke bare at lave 3D-printet. Det er alt det, der kommer efter med at bearbejde emnet, og man virkelig skal være god til. Og det, som en lille virksomhed, vi har ikke nogen maskinpark, vi har ikke know-how hverken til at lave 3D-print i de her materialer, og heller ikke til den efterfølgende bearbejdning. Så det er vigtigt at finde en partner, som kan, ja, her fandt vi så en, som kunne begge dele, men ellers skal man finde en, som er god til 3D-print, og så også finde en, som er god til at bearbejde emnerne. Så vores designer, han kom tilbage med det, vi kalder et marguerite-design. Det ved jeg ikke, om I kan forestille her på billedet. Det har den her marguerite-form. Og det er faktisk smukt, og det understøtter også vores brand som værende dansk håndværk og design. Så den sad lige i skabet. Og så skulle vi jo til at prøve at se, hvordan kunne vi udnytte den her topologioptimering. Vi ser på det billede her til højre, så har vi simpelthen udhulet det. Vi kan se, der er simpelthen huller igennem, og selv egerne, som er faktisk i forvejen er meget, meget tynde, de er også hule indvendigt. Og selve kroppen er også hule. Så på den her måde, så har vi, selve tænderne er også hule indvendigt. Så på den her måde, der har vi fjernet hver et milligram, som er muligt på det her produkt. Og samtidig givet det et fantastisk flot design. Og så hvis vi tager selve hvad hedder det, nu kan jeg ikke lige se på mit eget billede her, jo, udviklingsfasen, ja. Ceramics Beat, vi fik oplyst designgrænserne teknologisk, og det er primært de her minimums godstykkelser for den her, fordi vi vil gerne topologioptimere så meget som muligt, men der er også en grænse for, hvor lille en godstykkelse man kan printe i. Og den fik vi oplyst vi gav dem det her design, og så vendte de tilbage og sige, hvor langt kan vi gå ned i godstykkelse de forskellige steder. Og så, det er sådan en iterativ proces sammen med teknologisk. Og så blev der udarbejdet en 3D SolidWorks model af det færdige produkt. Og som jeg lige har nævnt, så havde vi en sparring med teknologisk hele vejen igennem, indtil vi havde den her model, som rent faktisk kan 3D-printes og kan holde. Og grunden den der kompleksitet og præcision og krav om et eksklusivt materiale, og det er så titanium, vi har valgt her, så faldt valget hurtigt på SLM, det vi kalder Selective Laser Melting. Det lå ligesom i kortene, det var det, der skulle bruges til det her. Og det er jo nogle ret kostbare 3D-printere, som man som en lille og mellemstor virksomhed jo ikke har mulighed for at købe. Ikke endnu i hvert fald. Teknologisk, de arbejdede herefter faktisk meget selvstændigt med bearbejdningstillæg og selve AM-processen. Og det viser også, at nu har jeg haft møder med dem og set, hvordan de har fulgt dem under hele processen, og det viser også, at det der med at beherske svejsningen af hver eneste lag med pulver, man tager ud på pladen, det er faktisk nøglen til succes. Fordi et emne, der er svejst forkert, det vil ganske enkelt vride sig, når det færdige emne vil have vreden sig. Ligesom det er ikke anderledes, når man står og svejser i almindelig stål. Hvis man svejser i en forkert rækkefølge, eller gør noget forkert og ikke tager hensyn til, at stål det faktisk trækker sig sammen, efter det har været rødglødende, jamen så får man noget, som er meget, meget skævt, når man er færdig med at svejse. Og det viser, det er jo det samme når man 3D-printer, fordi det er et lag pulver, du så svejser sammen. Så svejseren, den kører faktisk sådan meget, jeg har ikke forstand på det, men det har de. Så den svejser en lille streng, og så går den over et andet sted og svejser en streng, og så på den måde får de fordelt varmen, så de indre spændinger ikke gør, at emnet det vrider sig. Yes. Og så kom det næste, det var jo implementeringen på markedet. Og der indgår 2 puljehjul i hver oversize, og de blev cirka 12 gange dyrere end dem, vi normalt bruger. Og dem, vi normalt bruger, det er maskinarbejdet aluminium, der er anodiseret. Og I kan godt forestille jer et aluminiumspuljehjul i samme størrelse. Der skal jo en ret stor klump aluminium, og så bliver det stort set det hele der er måske kun 5% tilbage i det færdige emne. Resten bliver bare til skrot aluminium. Så her er der virkelig tale om, at man ren bæredygtighedsmæssigt sparer en masse materiale. Til at starte med, så bestilte vi kun emner til 20 styk oversize, da salgsprisen den blev meget, meget højt. Det var faktisk 1.600 € for sådan en oversize til sin cykel. Hvis ikke man er cykelentusiast, så kan det godt lyde mange penge, men 1.600 € er ikke mange penge, når man har det som sin eneste hobby og går rigtig meget op i det. Så er det ikke unormalt at bruge 1.600, hvis man har haft en god dag, han har sagt. Det er mange, der gør. Det er i princippet, hvis man har en interesse og en hobby, jamen så, det ved vi nok mange af os, at så kigger man ikke så meget på prisen, så køber man de ting, man synes, der er lækre, og som gør en glad. Og det er så en helt anden kategori end for eksempel Danfoss og Airbus. De kigger jo hardcore på den her value for money. Men vi giver også vores kunder value for money, for ellers vil de ikke købe produktet. De her 20 styk, det var sådan en limited edition, vi ville lave. De blev solgt på meget få dage. Og okay, så må vi jo lave nogle flere. Og heldigvis så kunne Teknologisk Institut hurtigt producere flere. Og det er så den helt store fordel ved AM, det er, at man kan jo i princippet trykke på knappen, og så kan man ret hurtigt producere nogle flere emner. Og det endte faktisk med, at vi indførte produktet permanent i vores produktportefølje. Og den er der stadigvæk. Og vi har solgt rigtig mange. Jeg vil ikke afsløre det endelige antal, men det har været en rigtig god business case at lave det her. En anden meget stor fordel for os, i og med at vi laver et produkt, som indgår, som vi rent faktisk sælger, det er, at det er en lille batch, det er cirka 30 styk, eller 30 sæt ad gangen, og dermed en lille lagerbinding. Det er også meget vigtigt for en lille virksomhed som os, at vi ikke binder alt for mange penge i lager. Yep. Så er der next level, jeg lige vil bringe på banen også, det er, at i 21 der deltog vi i et støttet projekt, hvor vi også sammen med teknologisk kunne finde en coating, der øger levetiden på puljehjul. For I kan forestille jer, at når der render en kæde igennem her, når man har kørt nogle 1000 kilometer, så vil det, uanset hvad man gør, så vil det give noget slid på de her tænder og på materialet i de her puljehjul. Man kan køre i regnvejr, der kan være sand på kæden, der gnaver og så videre i materialet. Så vi gik ind i et projekt med at finde en coating, der øger levetiden. Og for at gøre en lang historie kort, så blev resultatet, at vi nu også tilbyder det her produkt med TIN-coating. Det er utrolig slidstærk materiale, som man lægger ovenpå. Og det har så en rigtig stor sidegevinst. Det ser fantastisk godt ud, at det ser ud til, at de er lavet af guld. Kunderne har faktisk taget rigtig godt imod den her mulighed for endnu mere eksklusivitet i og med, at vi får den her fantastiske kulør rent faktisk. Og så samtidig med, at den har en øget slidstyrke. Jeps. Det var sådan set, hvad jeg havde forberedt til i dag. Så er der spørgsmål, så fyr løs.
Mange tak, Carsten, og det er der i hvert fald også i den grad. Jeg har i hvert fald et par stykker. Den her pointe i forhold til lagerbinding, det er jo tit sådan lidt en overset ting, når vi snakker AM og de her sådan mere digitale produktionsmodeller. Tit så hører jeg, at det mest bæredygtige produkt, det er det, vi ikke producerer. Og det er jo fordi, at man ikke at man ikke anvender materialer, vi ikke anvender energi og alt det her, som vi gør, når vi producerer ting. Har I overvejelser om ligesom, for jeg kunne forestille mig, at I har en kundegruppe, som er villig til at vente en lille smule. Altså middle-aged men in lycra som mig selv. Jeg kan godt vente et par uger, hvis jeg får det rigtige gear. Har I overvejelser om at tage flere af jeres produkter og lave sådan en model, hvor I faktisk slet ikke har lager på dem, men venter til kunden har lagt ordren og betaler, og så først trykker print eller producerer?
Nej, det har vi ikke. Fordi os middle-aged i Lycra, når først vi er besluttet for, at vi vil have noget, som gør os glade, og som er sådan en luksusting, så er det meget vigtigt, at man har det dagen efter, man bestiller.
Modtaget.
Det vil ikke være gangbart. Men vi har, når det så er sagt, så det er det første produkt, vi har lavet som 3D. Og vi er sådan set i gang med det næste produkt, som jeg vil ikke lige afsløre her, hvad det er. Men det er klart nu, når man har haft succes, det er jo også som Niklas han sagde, at start småt, få nogle succes, og så bygge videre på det.
Ja, helt sikkert. Og I har jo også et projekt sammen med os, som jeg skal fortælle en lille smule om. Jeg skal ikke fortælle, hvad det er konkret, I laver der, men mere fortælle om det projekt og de muligheder, der ligger der. Fordi noget af det, som vi jo selvfølgelig synes er super interessant, det er det billede, hvor du viste hjulet, hvor det er åbent, og man faktisk kan se, at der ikke er materiale indeni. Det er jo ret vildt, rent produktionsmæssigt. Det at få tal på det, altså få beregnet, hvad er det så rent faktisk, man sparer her i CO2e? Kan I bruge det i forhold til jeres forretning og jeres markedsføring? Altså hvis man kan gå ud og sige, det tandhjul, margarithjulet her, jamen det er sådan set, 10-20% mere bæredygtigt med de forbehold, man skal have, når man siger det, i forhold til et andet tandhjul. Vil I kunne bruge det i jeres markedsføring over for jeres kundesegment?
Ja, det vil vi gør det ikke i dag, fordi vi er så centralt nok med at udvikle og producere emnerne og få dem leveret til kunderne, men vi har rigtig meget fokus på bæredygtighed. Der er gang i mange tiltag. Og Herunder også skal vi selvfølgelig gøre opmærksom på, at vi sparer materiale, når vi laver 3D-printede emner. Men vi har også gang i nogle andre ting, det er med, at man får det retur og få det, så sikrer vi, at det bliver smeltet om og så genbrugt. Blandt andet.
Yes.
Det er jo ikke noget med 3D eller AM.
Nej. Jamen, super. Carsten, du skal tilbage til Tour de France, så vi er sikre på, at Jonas Vingegaard, han tager den i år, og Asgaard vinder den i København og alt det der. Jeg vil bare sige tusind tak for din tid, og tak fordi, at du var med her, og tak også for din deltagelse i vores projekt. Og vi kommer til at høre meget mere til jer, fordi at I har set lyset nu i forhold til den her teknologi, så jeg glæder mig bare til at følge det. Så mange tak. Yes, og det er nu mig, der står mellem jer og en kølig drink herinde, og måske en fyraftensøl derhjemme, så jeg skal gøre det kort i forhold til, hvis man sidder derude eller her og tænker, hvordan kommer jeg nu i gang? Lynhurtigt i forhold til, hvad Dansk AM Hub er for en størrelse. Vi gør alt, hvad vi kan, som sagt, for at få AM ud i industrien. Vi har skabt, første gang havde vi den i 19, og vi har skabt Skandinaviens største konference på AM. Vi gør, hvad vi kan for at kortlægge, hvordan det går med AM i Danmark, og det går faktisk fornuftigt. For 4 år siden, da vi startede, der brugte 18% af industrivirksomhederne AM, og i dag er det 32%. Så det er rigtig stærkt derude, og vi ser mange af de fordele, som vi også har hørt heroppe i dag, spredt rundt i forskellige industrier og spredt rundt i vores produktionssystem. Vi vil gerne være kerne af det danske økosystem, altså alle de dygtige forskere, aktører, printaktører derude, AM-udviklerne, som vi så fint kalder dem, og hjælpe dem med at finde de rigtige produktionsvirksomheder omvendt, sådan så vi sikrer, at man virkelig har let ved at komme i gang med den her teknologi. Som jeg startede med at sige, så har vi lige været i USA. Det er sådan, at den her teknologi jo særligt vokser der, hvor man har meget store emner, meget tunge og dyre emner, for eksempel i flyindustrien, som vi har set i dag. Og vi gør, hvad vi kan for at prøve at finde de aktører, som vi synes, der kan noget super fedt på for eksempel sådan noget som bæredygtig produktion eller på generativ design, og så prøver vi at lave projekter med dem, sådan så SMV også har mulighed for at se noget af det allernyeste teknologi her på dansk jord. Og derfor så har vi en kæmpe stor projektportefølje. Det her det er bare nogle af dem, men jeg kommer tilbage til det igen. Det fede ved det er, at som Ceramic Speed for eksempel, at der faktisk kommer nogle cases ud af det, som man kan gå ind og se på vores casearkiv og blive dygtig til, hvad ens nabo faktisk også har lavet af forskellige ting med AM. Vi vil gerne i lille Danmark være dem, der allerførste gang tager den her dagsorden til det næste niveau. Og det næste niveau, det er at kunne dokumentere, at når man bruger AM, jamen så har man elimineret CO2, eller man har gjort noget i den anden retning. Det er vigtigt, at vi begynder at få det bud på det. Vi har selvfølgelig Lca'er, og de projekter, vi laver, dem regner vi alle sammen Lca'er på, og regner så ud, jamen, hvad betyder det i forhold til CO2-ekvivalenter. Den her bliver lanceret sidst i det her år. Og så gør vi faktisk også noget inden for byggesektoren, hvor vi prøver at bruge de dygtige designer og arkitekter, vi har herhjemme, prøver at give dem mulighed for at arbejde sammen med nogle af de dygtige AM-udviklere, også internationalt. Og så vil vi rigtig gerne prøve at skabe en dansk AM-bygning, og det kommer jeg også til at høre meget mere om på et senere tidspunkt. Men tilbage til dansk industri og AM Hub. Helt grundlæggende så vil vi gerne være verdensførende i at anvende AM til bæredygtig produktion. Vi tror ikke på, at Danmark bliver størst inden for AM, og vi bliver heller ikke hurtigst inden for AM, men vi kan faktisk godt være dem, der er allerbedst til at bruge den her teknologi til, hvordan laver man en mere bæredygtig produktion. Som jeg startede med at sige, så er bæredygtig produktion jo sådan lidt et underligt ord, fordi det findes faktisk ikke. Fordi i det øjeblik, vi skal producere noget, så bruger vi materialer, vi bruger strøm, og så er vi på den negative regnskab. Men vi kan jo være dem, der er super gode til at sige, at min produktion er sådan her i dag, og nu brugte jeg noget andet teknologi, og så er den sådan her. Og hvad er forskellen på de to? Og hvis vi kan dokumentere over for udlandet, jamen vi er faktisk dem, der driver den her dagsorden frem, så vil de også begynde at være endnu mere interesserede i at lægge nogle af deres investeringer i vores land, og så kan vi få den her rigtig gode synergieffekt for vores industri. Det her er bare nogle af de aktører, som er gået med som medlem hos os. Jeg tror, vi har cirka 80 medlemmer lige nu. men vi er noget for den samlede danske industri, og skal være noget for den samlede danske industri. De her aktører går typisk med, fordi de får en lille smule ekstra i nogle projekter eller andet, og så følger de os gerne i nogle år, indtil de har stiftet godt bekendtskab med AM-teknologien. Så når vi tænker på AM, og hvordan den skal skabe forskel, og hvordan den kan skabe forskel, så har vi den her matrice i forhold til, jamen forandrer den mit produkt, eller forandrer den min værdikæde, gør den ingenting, eller gør den begge ting. Og man kan sådan set i alle 4 hjørner her skabe fantastiske resultater med AM. For eksempel en maskinfabrik her, Johannes Pedersen i Viborg, som var med i et projekt hos os, og som derefter bare besluttede at lave et 3D-printcenter. Det her det er en underleverandør til den tyske bilindustri, og det vi gjorde her, det var, at vi satte Johannes Pedersen op med Steffen fra Danfoss, og så snakkede de ellers om, jamen, hvad er vores erfaring, og hvordan kan vi hjælpe hinanden. I dag så er Steffen ikke ved Danfoss mere. Han er CTO i Dansk AM Hub, og han rejser simpelthen rundt til produktionsvirksomheder i landet, som måtte have spørgsmål i forhold til AM, men som også har lyst til at komme i gang med den her teknologi. Så ræk endelig ud, hvis der er nogen af jer, der sidder derude og har lyst og mod på det. Vi har jo snakket rigtig meget om skræddersyede produkter i dag, og mere bæredygtige produkter. Det her det er Rasmus fra Danitech i Haderslev, en 100-mand stor virksomhed, som i gamle dage ville producere en hydraulikblok på den her måde, men som faktisk for 1,5-2 år siden med god hjælp fra Force Technology og Teknologisk Institut fik 3D-printet en helt ny hydraulikblok. Dobbelt så effektiv, halvt så meget materiale. Super resultat. Vi har også nogle super spændende iværksættervirksomheder i Danmark. Dem her, de printer knogler, så rigtigt knoglemateriale i printer. De hedder i dag også i form, i gamle dage hed de Particle 3D, men der sker rigtig meget i Danmark på det område, som vi også støtter op om. Og så Sten her fra DVT i Frederikssund, som har lavet den ting i sin forretningsmodel, at han lover reservedel de næste 30 år til sine kunder. Kunderne køber sådan nogle sorteringsanlæg her af ham. Og hvis man kan printe dem, i stedet for at man skal have det lager liggende, så har man sådan set fat i den lange ende. Så det har han arbejdet nøje med i vores projekter. Godt. Så hvis I vil i gang hernede i venstre hjørne, og I vil gerne skabe hurtigere og nye prototyper og værktøjer, hvad kan I så gøre? For det første, så vil vi rigtig gerne, om I er medlem eller ej, vi vil rigtig gerne have, at Steffen på et tidspunkt kan komme forbi jer. Der skal ikke være nogen tvivl, at Steffen han har rigtig travlt lige for tiden. Men lad os prøve at sætte os ned og prøve at kigge på de her forskellige muligheder, hvad det er. For det er svært, altså, og der er mange ting. Og nu har vi hørt nogle rigtig gode og også ambitiøse eksempler i dag. Men alle produktionsvirksomheder kan få gavn og glæde af den her teknologi. Det handler bare om at sætte sig ned og se mulighederne. Det kan også være, at man ikke lige har lyst til at betale for en printer. Jamen, så kan man låne en printer af os helt gratis. Den stiller vi ud til jer, og så kører vi ellers igen, og så samler vi den op en måned efter. Det kan også være, at man tænker metalprint, hvor der jo ligger nogle af de her store bæredygtighedsgevinster, som vi har set i dag. Der er rigtig mange, der er ikke så mange printer, men der er rigtig mange gode aktører i Danmark på det her område, og der kan vi også hjælpe jer videre med at finde de gode forbindelser her i landet. Som jeg lige viste i forhold til Steffen, da han var i Danfoss, så kan man også få en AM-mentor. Det her, det var Videx, som gik sammen med Scandinavian Packaging, og der skal I også bare endelig række ud til jer, række ud til os, hvis det kunne være noget for jer at komme i gang med det. Gå endelig ind og kig på vores cases. Det er efterhånden over 3-4 år bygget nogle rigtig, rigtig solide cases op, som kan inspirere jer og række endelig ud igen, hvis det er noget for jer. Og så har vi Europas største AM-messe findes i Frankfurt, som hedder Form Next. Og her samler vi en dansk delegation af de producenter, som vil med derned. Og det gode det er, at de dygtige AM-aktører, vi har, nogle af dem kan faktisk også spille guitar. Så det bliver rigtig hyggeligt at sidde i den her danske delegation i den bus på vej til Frankfurt i november. Så der må I endelig række ud. Vi kan også hjælpe jer i forhold til at navigere lidt dernede, hvad man skal se og andet, for det er en kæmpe messe. Og så håber vi selvfølgelig at se mange af jer her til den 7. september, når vi igen holder AM Summit den her gang i tab 1. Jeg vil tro, vi har en 30-35 talere, alt fra Boeing til Lego til EOS til Teknologisk Institut til Damvi og rundt omkring. Altså alle dem, der ved noget om det her område, både på den tekniske og den forretningsmæssige side. Og der vil også være udstillere, og der vil være en masse sjove ting, som vi vil kommunikere om i de her dage. Hvis man vil i gang med de mere skræddersyede og bæredygtige produkter, så har vi i gang sat et projekt med Teknologisk Institut og PLM Group og Wikifactory og den internationale, jeg tror det er startet som en svensk virksomhed, men i dag er de meget, meget store og internationale, der hedder Hexagon, som laver de her platforme for generativt design. Og der har vi lige nu 15 virksomheder, som arbejder med, hvordan man kan designe det her. Og herunder blandt andet Ceramic Speed, altså hvordan kan vi få de her fordele ud af den her printproces ved at designe på en ny måde. Og jeg har talt med Teknologisk Institut, og jeg kigger op på Brian, og han nikker, det gør han nu i hvert fald, yes tak, at hvis der er nogen derude, der tænker, at de gerne vil med i et forløb her, så finder vi ud af det. Ræk ud til os, og så finder vi ud af, hvordan I kan komme i gang og godt videre, også i ly af det her projekt. Godt på forretnings- og cirkulære produktionsmodeller. Her har vi startet et projekt, hvor vi arbejder med unge. I sidste år havde vi 250 i et forløb hos os, hvor vi prøver at vise dem, hvad man faktisk kan med AM, og hvordan man kan skabe mere cirkulære produktionsmodeller med den her teknologi. Det er et super forløb, så hvis I har nogen alt fra lærlinge, eller nogle studerende, eller nogle unge derude, som kunne tænke sig at komme i gang med det, så samler vi faktisk 400 af dem op i efteråret i et arrangement ved Herning, og i Aarhus og i København. Og så har vi også på de nye forretnings- og cirkulære produktionsmodeller de mange startups, som jeg har nævnt, og det her det er blot dem, der er medlemmer hos os. Der er mange flere, som arbejder med den her teknologi og formår at skabe en ny forretningsmodel på baggrund heraf. Vi har noget, vi kalder Venture Day, hvor vi bringer dem sammen med internationale AM-kapitalfonde. Sidder der nogen af jer derude, så skal I simpelthen med der, så ræk endelig ud til os efterfølgende. Godt, sidste pointe, det er, at noget af det, vi slet ikke har snakket om i dag, det er værdikæder. Og det er jo ellers noget, som er meget op i tiden, må man sige. Altså få ændret lidt i sin værdikæde i de her dage, så den måske er lidt mere robust, lidt mindre udsat over for kriser og krige. Man føler næsten ikke, man burde sige det. Men måske jo også i den forbindelse faktisk, så den i sig selv kunne blive en lille smule mere bæredygtig. Det her eksempel er et, der har inspireret os meget fra Signify, datterselskab, til Philips, hvor de i stedet for at have den her sådan kæmpestore centraliserede produktion tit i udlandet med mange skibe, som sejler fragtruter osv., så har de lavet små 3D-printcentre tæt på kunderne, der aftager deres produkt, og de trykker først print, når kunden har beordret den. Og dermed så sparer de en masse CO2 og har lavet en mere robust værdikæde. Der kommer et projekt i det i 2023. Hvis det er noget, I er interesseret i, så rækker også ud til os. Så det var alt for i dag fra os. Vi nåede det lige præcis på de sidste 2 minutter her. Tak til alle jer, der var med derhjemme. Tak til jer, der var med her i dag. Selvfølgelig thanks to Niklas, thanks to Bastian, tak til Carsten derhjemme. Og jeg tror bare, det eneste, jeg vil sige, det er, at hvis man vil i gang, og hvis man også vil videre med teknologien, så rank endelig ud til os, fordi at der er masser af muligheder for at komme i gang. Mange tak.